Hi all, my name is Bhavyashri and this is the video of continuation of grade 6 physics lesson number 1 matter. In this video we'll be seeing the continuation of matter in this video. In the last video we saw the 5 characteristics of particles of matter. We saw what is atom, what is molecules and what are, how did they come to existence and who named them first and who was the person who named them in a modern term. So we saw all of that and we saw the 5 main characteristics of atoms and molecules. What are they? Let's recap once. They are very small in size. They have space between them. They're constantly in random motion. They always attract each other. We saw about these 5 theories in detail. In this video, we'll be seeing the conclusion of this and the states of matter and the properties of solid. So let's go to the lesson. Yay, let's go. Let's see the conclusion of the last video. This is also a fun fact we will read. Conclusion. Matter is made of molecules which are so small in size that -10, -9 millimeter, like it's so small that you can't even see with the naked eye. The molecules are in constant random motion. They extract a force of attraction among them. They have intermolecular spaces between them. What is intermolecular space? Correct. Intermolecular space is the space between the molecules and the gaps of the matter. So there's a note. A molecule is a cluster of several molecules called a nanoparticle. So if a molecule is a molecule or a cluster of molecules are known as nanoparticle. So there's actually a fun fact. The force of attraction, did you know? The force of attraction between the particles of same substances is called the force of cohesion. Like the conclusion, like the force between the two same substances is known as cohesion. Next, or the cohesive force. While the forces of attraction between the particles of two different substances is known as adhesion force or adhesive force. That means between the same substances it is a cohesive force, whereas it is different substances known as adhesive force. So this is the two main terms that are used in molecules of matter. Now let's see states of matter. Okay, in general, how many states of matter are there? Correct, there are 3 types. What are they? You're correct, they are solid, liquid and gas. These are the 3 main molecules of matter. They're not like the only 3. There are more. There is more particles in matter, but these are the 3 main. Let's study about them in detail, shall we? Okay. So there are 3 physical states of matter: solid, liquid, and gas. For example, steel is solid, oil is liquid, oxygen is gas. While air is a mixture of gases. Okay, listen to me once. There is a difference between mixture and solutions. Don't get confused. Mixture means it's just a cluster of them. Now, okay, there will be a cluster of balls or whatever. Now these both are together. They are mixed together. It doesn't mean they both are one. No, this is in green color. This they are. Even though they're together, they do their own work, right? Like if in your classroom you'll be reading, if the man gives you a work, everyone will be together, you'll be in the mix in the class, right? You'll be doing your own work. Like that, mixture is just like a group of molecules or atoms, but they perform their own properties. But solution is like it's fully mixed. Like you can take a salt solution, there's water and salt. If you mix it, you can't separate it, right? Like that, mixture is something that is mixed, and whereas 2 molecules perform one action, but a mixture actually performs each molecule with its own properties. Okay, remember the state, mixtures and solutions. Don't get confused between them. Water can exist in all 3 states. Now, do you know actually water can actually be in all three states. In solid, it can be froze. In liquid, it's water. Gas. What is gas? Water vapor, of course. Whenever you boil it, the vapors coming out of the bowl are known as water vapor. If you close the hot tin and if you remove it after it cools down, you'll see droplets to the cap. Why? It's condensation. So water exists in all 3 states. Okay, like I said, ice is solid state, water is liquid state, steam or water vapor is known as gaseous state. Okay. Do you know plasma is the 4th state of matter which was found at a very high temperature when the gas occurs in the form of positive ions and free electrons. See, there is not only these three, there's one more. What is its name? Plasma. The three properties which decide the state of matter is a substance or a liquid or a gas. Like these are the three properties which decide whether it's a solid, liquid or a gas. First, the intermolecular space between them. Force of attraction between the molecules and between the attraction of molecules and the movement of the molecules. So these are the three things that you should know whether they're in a solid matter or a solid, liquid or a gas state. Now let's see a solid and liquid gaseous state in detail. Okay. So solid state. When intermolecular force of attraction is very strong and the intermolecular space is negotiable and molecules are not free to move, matter exists as solid. The solid state is, it can't be free, like it should be like together. Now see, there's a very strong attraction between this ball, because see, even then pulling it, it's not going. Why? Because there's a lot of molecules and the force of attraction is so strong that it's not going off together, and they can't move freely, like they're just congested and staying in one small particles. They don't even have the right to move because there is not even a space remained. So that is known as solid state. Liquid state. When the intermolecular force of attraction between the constituent molecules is weak, intermolecular space is more as a compound to solids and the molecules are free to move, and for within a limited space, matter exists as liquid. So liquid also has the same, but the there will be a little bit of intermolecular space compared to solid. It is free to move but within the boundaries of the tumbler or the container you pour into. So if you pour water into a glass or a tumbler, then it can only move inside the tumbler, but it can't go outside. It can only occupy the space given to it because it doesn't have a definite shape or volume. Now let's see gaseous state. When the intermolecular force between the constituent molecules is very weak and negotiable, the intermolecular space is far more and as compound to liquids. So gaseous state, now like they will be like roaming all around the room. They have no limits because they cannot be captured, they cannot be stored. They will be moving wherever they are because oxygen molecules are moving everywhere, right? So gaseous has a lot of intermolecular space and it's very weak. So this is the detail about solid, liquid and gas. Now let's see the properties of solid. We're going to be studying more deep about each state. Let's see properties of solid, shall we? Okay. First one, a solid has a definite shape and size. For example, length, area and volume. Now let's take this small paperweight for example. Like it's circle in shape, it's green and it is really hard that it can be like a stress ball actually. So this is the explanation of this toy that I'm having right now. So a solid cannot be compressed. Like this is also solid, but I can compress it because it is made like to compress it. But some things like these toys cannot be compressed because they are really there because they are not meant to be squeezed or compressed. The solid cannot flow. That means solids can just flow away. They will be in a one single shape that it has been given. Solid has a high density, like it is really high in density. Even though it's compressible, but it's still having a high density and it can't be compressed like this. It can only be squeezed like this. A solid and its constituent molecules are very closely packed. I told you already. The solid intermolecular space is very strong. There is not even a single so small space because they're all packed so together, close together. A solid expels pressure due to its weight only on its base downwards. So this thing only has this weight going downwards, pulling downwards because due to the gravitational force of the earth. A solid has a strong intermolecular force of attraction. A solid has a low thermal expansion. It expands a little on heating. So okay, for example, I'll tell you a small experiment. Take a ball. A metal ball and a small hoop. Then you first put the ball, make sure the hoop is bigger than the ball. If you put it through, it will go through. Then heat it a little bit, it will expand. If you try putting it again after it cools down, will it go in? No, because it's already expanded. It's not in its form to go in, right? So that's a little experiment, but be careful. Okay. In a solid, the molecules are not as free to move from their positions. They simply vibrate on either sides of their mean position. Like, it doesn't mean they never move, they just vibrate in their mean positions. A solid can have any number of free surfaces. A solid is a highly rigid, but some solids can be stretched into wires or bended into sheets. Like, the copper wire that we have, it can be bended or like made into sheets, right? So some solids can be made as sheets and also be bended. A solid does not easily diffuse into other solids. Like, I have these both. Are they mixing? No. Like that, they don't diffuse. Diffuse is nothing but getting together as water. Okay, for example, if you have water and a food coloring, if you put the food coloring, immediately it will like change color, right? Like because it has intermolecular space, but they don't have intermolecular space, so that's why they don't mix together. A solid does not easily the above mentioned properties of the solids can be explained by molecular model of the solid state. So if you see a molecular model of a solid state, they'll be so closely packed together that you can't even see. So that's about solid. See you guys in the next class. Bye all.